Hi, good morning. This video is going to go over the diagnostic test, questions 20 and 21. Now, both questions, if you've read them before when you took the practice test, you might notice that they're both sample questions. So this top one looks like a sample population, sample proportion question. So I'm going to start out by reading it. A city official in a storm damaged region of the U.S. believes that the percentage of homes with contaminated water is higher than the recently reported value of 9%. Now, immediately I'm thinking, aha, somebody has a belief. That sounds like a hunch. So right there, the word believes, I'm going to circle. Sounds like a hunch. And the hunch is that it's something higher than the 9%. So the reason why that's important is it looks as if they're going to use a sample to make an inference about a population. And that's exactly what Chapter 7 was about. So as I look at this, I say to myself, is this a categorical question or a quantitative question? So I keep reading, and I notice that they took a sample of 168 homes and found that of the sample, 23 of those were contaminated with water. Is there enough evidence to conclude that the initial report was too low at a significant level of 0.05? So that other significant level gives me the idea that that's alpha. So if alpha is 0.05, which is actually what we typically assume, then I need an H sub O and an H sub A. H sub O is the accepted truth, so it sounds as if the accepted truth that it's 9%. Now, I like this question because if water is contaminated, that's actually an example of something could be quantitative or could be categorical. But in this setting, it doesn't look like we're measuring the water in parts per million of contaminants, nothing like that. We're asking if your water is contaminated, yes or no. And so a yes or no question would be categorical. So when I take a look at this, it appears as if when it's categorical, we write H sub O and then P sub O. So P, or you could also say P naught. So the P naught is 0.09. So before the sample was taken, it's the accepted truth that 9% is contaminated. And so your H sub A is that it's something higher than that. So you believe that there's more contamination than that. So I'm going to write P sub A is something greater than P sub O. Or you could have written something greater than 0.09. Now, if this was a free response question, you'd define each of those, but it's really just a multiple choice. So I'm going to keep going, and I look at my samples, so that's my P hat. I had 23 out of 168, and so when I divide that, my easy calculator, I get 0.137. So that's going to round to 14. So it appears as if 14% in my sample. And so it does look like I have some amount of evidence that the percent that is contaminated is greater than 0.9. I'm feeling pretty good. But ultimately, I have to figure out what's the probability of getting this outcome if based purely on chance. And that's when I need my fancy calculator, because I need a p-value. So I get my fancy calculator here, and I want to do a stat test. So I select stat test, I hit enter. And I noticed that I want to do a 1 proportion. It looks like we only took one sample of 168 people, and it's definitely a proportion, so that's called a 1 proportion z-test. I click that, and I feel really good about myself because I have information exactly as they have it here. P naught, we said the accepted percentage is 0.09, so I type 0.09. The success, it's a weird thing, but yes, 23, we called success, you're contaminated. Then N is 168, so 168. And then this is the clincher here because I'm noticing that either I'm saying yes or no. And I also noticed that they give me a p-value of 0.017 or 0.034. So I'm kind of cluing in that I need to decide, is this a one-sided or a two-sided? And I'm noticing the word higher tells me that I believe my proportion is greater. So notice I'm going to decide to pick the proportion I believe is greater because that was the hunch. When I hit OK, I get a p-value of 0.0168. So that's going to round to 0.017. So immediately I notice two of those are there. And so now I just have to decide which one, these two came to the right p-value, which one came to the right conclusion. So as I look at that, if I have a p-value of 0.017, since it is less than 0.05, I'm going to say yes. Yes, I do have sufficient evidence to conclude that the contamination percentage is something larger than 9%. Next question. Very similar. It looks like you have a study and that you took a sample and that you're trying to make an inference about the population. So it says the random sample of 100 songs had an average length of 3.2. The sample standard deviation was 0.04. What is true? So we think about the math we can do, and right here in our formula book, I'm going to flip here to my formula sheet. There's actually a lot of information on your formula sheet about exactly this. So as I look at this formula sheet, get to this page here, I noticed they write a whole paragraph about it. Let's see if you can see that. Right there at the top. It says if X bar is the mean of the random sample, which is exactly what we have happening in this problem, of a size n, so we have a size of 100, from an infinite population with a mean of mu and a standard deviation of sigma, then these two formulas apply. And so that's exactly what we have, and those exactly are the formulas we need. So I'm going to write that on the side of my paper, that mu X bar would equal mu. So that just means the mean of the sample would equal the mean of the population. So if the mean of the sample is 3.2, then the mean of the population, those are going to be the same number. Mu sub x, 3.2, mu, 3.2. The other thing I know is they told me the sample standard deviation is 0.04. So sigma x bar is 0.04. I'm not going to call that sigma because they specifically said that's the sample distribution. Now writing my formula, sigma x bar is sigma over the square root of n. So I can actually work backwards and figure out what would be the standard deviation that I could think may be a fit for the population. So 0.04 equals sigma over the square root of 100, since they said we took a sample of 100. Square root of 100 would be 10. So that would make sigma, if I multiply 10 on both sides, 0.4. Okay, so what I'm noticing here, and this happens every time, that larger samples give smaller spreads. Because looking at this formula, the bigger this number is, the smaller this spread will go. So the bigger this number is, like let's say that would be 400, the square root of that would be 20, so that would be even smaller of a sample standard deviation. So I'm going to write that. The standard deviation, sigma, and I'll write the word population, is bigger than the sample's sigma. So, and we did that mathematically. Sigma is that's the standard deviation of the population, ended up being a bigger number because of this formula, which should make sense. So looking through my answers, it appears as if the only one that makes sense is if indeed all the conditions are met, and it appears as if it is. The first one says we took a random sample of 100. The average would be 3.2. I agree with that. And the standard deviation would be 0.04. Well, that makes me feel a little off because I know every time I take a sample, the standard deviation is going to be a little bit different. So this standard deviation I collected was just from a sample. What's to say another sample would give me exactly the same standard deviation? So next one says the sample distribution would be approximately normal. And that I would agree with, as long as a sample mean question meets all the conditions. And it would here because the number 100 is bigger than 30. And you could assume that there's at least 100 times 10 or 1,000 people in the population or songs in the collection. So you would say that it should be approximately normal. So I like that, but the problem is the variance of the population, it said, would be larger. And that doesn't make sense. Variance would be this same thing if I squared it. So if I square that, once again, if I square a larger number, it's still larger. The sign still remains. So now I'm going to skip down here to E in the interest of time, because these other ones fail for those same type of reasons. And I like this last one. The only thing I don't like about it is definitely I like that it's normal, but it says a standard deviation of another sample, or the sampling distribution, would be smaller than 0.05. Well, I think it's got just as good of a chance to be smaller or bigger. So I have to pick E because I'm eliminating the other ones for other reasons. There you go.